Humanities. We're going to start a new topic this term, and we're looking at the coast. Starting off by looking at waves and tides. And here we have a animation showing how the tides work, or in fact why they exist. If you look right in the middle over here, you can see the Earth spinning round and around. If you look carefully, the triangular shape, that's Greenland. And the little green and orange men standing on the surface there give you the sense of the daily rotation of the Earth. Now, over the kind of monthly scale, the moon rotates around the Earth too. What we're really interested in is this blue band that surrounds most of the Earth. That's the oceans and the seas. And as you can see, it's pulled towards the moon wherever the moon is. That's caused by the gravity of the moon. When the moon and the sun, which is over here, pulling in the same direction, it'll be higher. But what we're really interested in is just the fact that the Earth, in the area underneath the moon and in the area directly opposite the moon, will have higher water, will have a high tide. That's what it means. And those places that are 90 degrees to the line of the moon, so here's the moon, here's 90 degrees, these will have low tides. That's what causes the tides. If you wish to take notes on paper, you can. I will provide worksheets to go along with this work, and those worksheets will need to be filled in. But if you want to take notes on paper as well, or if you happen to have taken your books home, that's okay too. You can take the notes in your book. So here's the title, Waves and Tides, and in this lesson we plan to understand the causes and the nature of tides and waves. Now, during these lessons, you can obviously pause the video if you want to, and complete parts of the worksheet. You can also write questions to me on stream on Google Classroom. I'll be available all the way through the lesson time period. If you write on there outside of lesson times, obviously I'll respond to you, but it might take a little longer. So here we have that a picture or a screenshot from that GIF we were looking at earlier. Here we go. The moon is most important in causing the tides. It draws water toward it under the force of gravity. Therefore, some areas of the ocean have higher water than others. And those areas of high water are high tides. Areas of low water are low tides. So this area underneath the moon, or opposite that because the Earth is spinning, will have a high tide. And areas at 90 degrees to it will have a low tide. And here we can see it at Porthcawl in South Wales, which actually has one of the highest tidal ranges in the world. You can see here, this is the high tide, the water's halfway up the seawall here, and you can see this green mark just down here. That's where the sea normally gets to. That's this area. So all of this land here is covered up when the tide's in, and then exposed when the tide is out. I suggest at this point you just pause and go complete that part of the worksheet. Right, now that you're back from that, we're now looking at where waves come from. Waves are caused by friction of the wind on the surface of the sea. That's what produces the actual wave. Just like when you're blowing the top of your tea to cool it down, you make little waves. So much larger waves are made at sea by much larger breezes than you produce when you blow your tea. Now, the size and power of waves are very important, and they're controlled by three different things. One is wind strength. In this diagram, this orange wind is supposed to represent just a strong wind, whereas the pale brown or cream colour is meant to represent a weak wind. So B, simply by virtue of the fact it's a stronger wind, is likely to produce larger, stronger waves. Now, there's also a question of time. You can see that this wind has been blowing for 27 hours, whereas this one is 10. This one also 10. And so the one where it's been blowing for a longer period of time, that will produce larger waves. Longer period of time, more energy transferred to the surface of the ocean, therefore larger waves. And so if the wind has been blowing for a long time, it produces larger waves. Finally, we have to talk about fetch. Now, fetch is the distance over which the wind blows. Clearly here, from the land here down to island X, B has by far the largest fetch, and therefore the wind is blowing over a larger expanse of water and therefore will create larger waves. C here is somewhat larger than A, and therefore C would also produce larger waves because it's blowing over a wider expanse of ocean, even though both of them are relatively weak winds, both of them have been blowing for 10 hours. Still, the one with the largest fetch will have the largest waves. There's a section on the worksheet for you to complete on that, and it's answering these questions. Note, you have to justify your answers, and you should justify your answers making relative comments between wind C, wind A, wind B, and saying, I think that wind B will have higher or lower, stronger or weaker waves than wind A because, and then talking about the fact that the strength of the wind, how long it's been blowing, and the length of the fetch. Make sure you use key terms. Now, it's a very simple activity, and you need to demonstrate how waves form, and specifically you need to get the correct terminology. So here we have a wave. Waves out at sea are a circular movement of energy. As they come into land, they break. That's when they kind of arch over. That's the picture you see when people are surfing, yeah? Now, as the waves break and then crash onto the beach, they will drive material up the beach, that's called swash, and back down the beach, that's called backwash. Swash and backwash. These are important terms, that's why you have to redraw them on the worksheet. That's why you have to redraw the diagram on the worksheet and label swash and backwash. Quite often, later in this unit, you'll need to use these terms. Swash, material being pushed up the beach by a wave. This tends to cause deposition and lead to the building up of the beach, or construction. So they're called constructive waves. Waves that are steep and towering, have more energy and crash down onto the beach, tend to drag material off the beach. That's called backwash. That will tend to erode the beach. So they're destructive waves. Complete that activity now, please, and then come back to the video. Right, finally, we're looking at wind speeds in Koh Samui Airport. While we can look at waves over the short winds and waves over the short term, it's important to know about the prevailing wind, which one is most common, because the one that's most common tends to cause the greatest amount of damage to a beach, or the greatest impact. Now, prevailing wind is most common, and it's also important to think about the strength of these different winds. And to work out which wind is prevailing, which wind direction is most common, we're going to draw a windrose. On that windrose, this is in a sense a circular bar chart, and for each of these directions, so up here we have north, north, northeast, northeast, east, northeast, east, and so on. For each of these you need to make a plot. So you've got one of these on your worksheet. The first measure is east, southeast, so I'll have to go down here. Well, that's east, that's south, that's southeast. So east, southeast is this one, and I need 1 on east, southeast. For southeast, that's 1, 2, 3, so I'll have to colour in 1, 2, 3 blocks. There you go. Now I need to do west, and so there's 1, 2 readings for west. 1, 2, so I'll have to colour in these blocks, and so on. You'll also need to give yourself give it a title, and you have to label all of these compass points. Don't forget, if you're having problems, ask a question in the stream. If you're doing this outside of the normal class time, you can still ask a question in the stream. I'll try and get to it when I notice it, or you can send me an email. Once you've completed the worksheet, ensure that you turn it in so I can have a look at your work. Thank you.